Good everyone, my name is Graphics. If you look at the front of a screen, you will see a question, and the question says, the head of water over an orifice of diameter 40 mm is 10 meter. Determine the actual discharge and actual velocity of the jet at the vena contractor. Take CD equals to 0.6 and CV equals to 0.98. The orifice is an opening in the wall or base of a vessel through which the fluid flows. That is what we call an orifice. So when you are given a question like this, the first thing you have to do is write out your what? Parameters. The data given. Now the first one here is the diameter, right? And the diameter is given as what? 40 millimeter. And if I convert it to meter, it will be what? Dividing it by what? 1000, and that will give us 0.04 meter. Now I told you whenever you are given diameter, try and calculate for what? The area. It will make your workings or your solution easier in the later stage of the calculation. So the area here will be pi d square over 4, since the surface area we're talking about here. And what is the pi? Is 22 over 7, which is 3.142, multiplied by the diameter, which is 0.04 square, all divided by what? 4. By the time you do your calculation here, you have your answer for the area to be 0.001257 meters square. All together. Now, the next thing from the question is the head. The head here is given as what? 10 meter, right? I'll move forward, and we're told that we should calculate for the actual discharge. So we use Q for discharge sub A, which represents our actual discharge. We're looking for that. And the actual velocity, we use V sub A, which is equal to unknown, right? So we're looking for that too. Then the CD here is giving us the equation of discharge is given to be 0.6. And the CV here, which is the equation of velocity, is given to be what? 0.98, right? So these are the parameters given here. So we want to calculate for the first one, which is what? The actual discharge, Q. Recall, my quotient of discharge will be giving me the actual discharge all over the theoretical discharge, which is simply as saying Q sub A representing my actual discharge all over Q sub TH, which is representing my word theoretical discharge. But my Q sub TH, which is my theoretical discharge, is equal to what? The area multiplied by what? The theoretical velocity. And what is theoretical velocity? Is given as what? The square root of what? 2 times gravity times what? The head, h, right? Now if I now input it into my formula, I will now see my CD here will now be equals to Q all over, that is the actual discharge, all over the area multiplied by what? The square root of 2 times gravity times what? The head here. Now if we move forward, put in our parameters, my quotient of discharge is given as 0.6 from our parameters, equals to the actual discharge all over the area, which we calculated for earlier, is 0.001257, multiplied by the square root of 2 times gravity is 9.81, multiplied by the head, which is 10. So my 0.6 will now give me Q sub A, which is the actual discharge, all over 0.001257 multiplied by the square root of, if you multiply 2 times 9.8 will give you what? 19.62, multiply by 10 will give you 196.2. Now my 0.6 will now give me the actual discharge all over 0.001257 multiplied by the square root of 196.2 will give us what? 14.007, isn't it saying 14.01, right? Now my 0.6 now will now give me the actual discharge all over. If you multiply 0.001257 times 14.01, you have 0.0176. So if I make my actual discharge the source of the formula, my actual discharge will now give me 0.6 times 0.0176. So my actual discharge will now give me 0.0106 meter cube per seconds. So this is my actual discharge. Now the next thing we are told to calculate for is the actual velocity. Now recall, we know that my actual velocity is equals to what? We know that my coefficient of velocity will now be equals to what? Actual velocity all over what? Theoretical velocity, which is given as v sub a all over vth. Now the theoretical velocity is given as what? Square root of 2gh. Right? Now if I input my value, I'll be having 0.98 equals to actual velocity all over square root of 2 times 9.81 times 10. This will now be 0.98 will now give me v sub a all over square root of 196.2. That is when you multiply 2 times 9.81 times 10. Right? So my 0.98 will now be equals to the actual velocity v sub a all over 14.01. Now if you make my actual velocity solve the formula, we'll be having 0.98 times 14.01. That will be giving me my actual velocity. So the actual velocity will now be 13.73 meter per second square. So we have successfully calculated for the actual velocity and also the actual discharge. So this is how we go about it. So if you found the video helpful, please don't forget to like the video, subscribe to the channel, and also share the video. Thanks for watching.